Hi, so we're going to be on the Unit 3 packet, the original packet with page 24 being the notes. I am about to zoom in on this, but it's going to be page 24. And we're going to do portions of this and just record the 3 key concepts that I want you guys to get for this section. And this is section 5.5 in your textbook. So if you're referring to a section in the textbook, this is 5.5. Again, this is page 24 of the Unit 3 packet. We're going to go over the last bit of inequalities in one triangle. So if, let's say we use the figure for problem number 1 here. Let's call this problem 1. And if I were to physically measure this, this is length 3 centimeters on your paper. This side is length 4 centimeters, and this is 3.5 centimeters. The angle measures for angle B is 60 degrees. For angle A, it's 75 degrees. And for angle C, it's 45 degrees. All three add up to 180. So now taking a look at those measurements, part 2 is going to ask that we put the angles in order from least to greatest. So if I were to list out the angles from least to greatest using the measurement, I would say, well, measure of angle C is the smallest one, the lowest measure, and that's less than the measure of angle B, which is less than the measure of angle A. And remember that M in front of it talks about the measurements, and we're talking the degree value here. So C is less than B is less than A. Now, if we talk about the side lengths, we also label side lengths. A quick way of, for example, referring to segment AC or side AC is it happens to be across from angle B. So angle B is a capital B. For the side length across from angle B, we also call it little b. And so the side length across from big A is little a, and the side length across from big C is little c. So using those as the label of the sides, we would say, okay, well, if we were putting it from least to greatest, we would say C is the smallest, followed by B, which measures 3.5, and the longest side would be side A. Well, if you notice the order in which I had placed the angles from least to greatest, and then the side lengths from least to greatest, we come across our first inequality statement, which is how are the inequalities down below here? We'll summarize. This is part 1. How are the sides and angles of a triangle related? So we might hear this being referred to as side angle relationships. And we would say the shortest side is across the smallest angle, which is less than the medium side, which is across the medium measure angle. So medium angle. And then lastly, the longest side is greater than the other two sides. So the longest side is across the largest angle. And that makes sense in terms of the opening of the angles, determining how long the side is across from it. So now we're going to move on. Go ahead and take a second to refer to that. So anytime we're looking at an angle, its measurement in comparison to the measurement of the other two angles will depend on the length of the side that it's across. So that's part 1. Okay, and we're going to do an example using compound inequalities. Notice that the question at the top example here, it might be a little bit blurry, so let me clarify what these angle measures are. That's 29 degrees, and let me make my pen a little bit thinner. Here, this is 29 degrees. This is 121 degrees. And let's say that the inequality symbols are going in this direction. So that's a little bit backwards from what we're used to. What we want to remember is that the inequality symbol is open towards the measurement that is the largest. So in this case, it looks like they want us to write it from longest to shortest. And specifically, they're talking about sides. So if I don't have the third angle, what I'm going to do is add these two angles and subtract it from 180. So in doing that, I get 150 degrees. So this missing angle right here must be equal to 30 degrees. Now, if I wanted the longest side, I'm going to find the angle that is the largest. So the largest angle is angle S. That happens to be across from angle S is side RT. So RT is the longest, followed by the side across from 30 degrees, since 30 is bigger than 29. And that happens to be side RS. And then lastly, ST would be our smallest length of sides. In the next example, sometimes what they have us do is write the angles, and in this case, least to greatest, smallest to largest. So again, just in clarifying some of the numbers, this says 10, this says 12, this says 16. And so if I'm looking for the smallest angle, the inequality is a less than symbol right here, then my smallest angle would be across my smallest side, which is angle T. So the measure of angle T must be less than the measure of the angle across from the medium side length, which is angle R, followed by the measure of angle S being our angle across from the longest side. So that's an example of how we would see problems related to inequalities on sides and angles. Now, another type of question that they might ask, which is going to be summarized here under part 2, is they might ask us for possible range of sides. Meaning, given two sides of a triangle, what's the possible range in which the third side must fall? What's the smallest it could be? What's the largest it could be? So let's say you guys were given C is the third side of a triangle, and A and B are the lengths of the other two sides. We would say that if they asked you to find the range for the third side, given A and B, we would say that the third side has to be less than the sum of the other two sides, but greater than the difference of the other two sides. Okay, and we'll do a few examples on the next page for that one. Okay, so if you can now flip to, or actually let's do an example here so that it's right underneath this problem. Okay, so example number 1, let's say you were given A equals 4 and B equals 6. What is the possible range of the third side? Okay, so let's call the third side C. We would say C has to be between the sum of the given two sides, so 6 plus 4, so it has to be less than 6 plus 4, but greater than the difference, 6 minus 4. So C is going to be some value between 2 and 10. Those are the possible lengths of the sides. Okay, and our last theorem that we're going to talk about today, all of these are application theorems, meaning that we are expected to apply it, is called the exterior angle theorem. If you remember down below here, which one is the exterior angle? We would say 1 is the exterior angle, and just to relabel this so it's a little bit more clear, 1, 2, this is 3, and this is 4. So we would say that 1 is the exterior angle, and according to this theorem, and it'll make sense once we think about the exterior angle theorem, but the measure of any exterior angle of a triangle is greater than both of the non-adjacent interior angles. Okay, what does that mean? So we learned from before that the exterior angle, this is exterior angle theorem, not inequality theorem, but just regular exterior angle theorem. We learned that if you had the exterior angle of a triangle, that it was equal to the sum of the two remote interior angles. So in this case, 3 plus 4. Well, if that equation is true, then we would know, according to this inequality theorem, that the measure of angle 1, the exterior angle, if that represents the sum, it must be greater than 3. I mean, that makes sense. It can't possibly be less than 3 if it represents the sum of the two remote interior angles. So measure of angle 1 is greater than measure of angle 3. Similarly, you can conclude that 1 must be greater than 4 as well. So again, it represents the 1 being the exterior angle is the sum of 3 plus 4. So it makes sense to say that the exterior angle has to be bigger than each one of the remote interior angles inside.